Patrick Humphrey's been working with Manulife over the last summer, and he has kicked on from that and focused his dissertation project on the technical evaluation of rock anglers. Floor is yours, Mr. Farmer.
Sweet. Thanks for coming along, guys. Yeah, as Ring said, my dissertation project is on the technical evaluation of grouted rock anchors for yard applications. So basically, to sum that up, it's just, are grouted rock anchors suitable anchors for guy lines for all applications? And to start, I want to give you a bit of a premises for this research. So that skid there is where the anchors are installed, and it's quite a steep terrain forest. Everything had to be inboard, so high construction costs. And that is a big spur there, so a lot of dirt had to be moved. So as you can see, there's not really a lot of room on that landing, and the tower is quite tall. So getting that angle between the guy line and the tower is quite difficult. So to save the environment a bit, we decided to install some rock anchors instead of actually digging a few dead men down the hill. So basically, there's 4 objectives to my research. Firstly, it's just to determine, are rock anchors suitable? Can we use them instead of mobile anchors or dead men? Secondly, I decided to provide some installation and testing methodology if forest contractors or management companies want to use these ideas for themselves. Provide some design information, again, if contractors or forestry management wants to use this, and then explore a few other alternatives where grouted rock anchors may be applicable. So as I said, 3 rock anchors were installed on the side of the landing, and to ensure safety for both the contractor and the forest management company, we conducted 2 tests, an acceptance test and a performance test. And before I go into that, I'd just like to give a quick brief of some costing. So it's about 2 to 15K to install 1 grouted rock anchor. Obviously, it gets a bit cheaper if you're installing multiple. And it's about $300 per meter for a tin, which you can see in the top left image. So the first test is the acceptance test, and this is basically done to ensure that the anchor meets the ACOP, especially the rule 14.1.4, which basically states that the anchor cannot be the weakest member in the chain. So the anchor must equal the breaking load of the operating rope or the skyline. And for this instance, that was 90 tons. So as you can see in the graph on the top, each anchor was loaded to approximately 36 tons, giving us a total of 108 tons, clearing that 90-ton minimum. And as you can also see, there's quite a lot of displacement on that graph, but that can mainly be attributed to the thimble deformation. So for future reference or for future tests, it's best to use a solid thimble to get more accurate results on the creek. And then the second test, which is a performance test, was basically just to see how well the anchors worked in actual working conditions. And what was noticed here is basically that rigging is a key part for anchoring, and if you get the rigging wrong, you can have imbalances, and therefore you're then in breach of the ACOP. And it was noticed that the highest maximum load was 20.2 tons acting on those anchors. So installation information. Basically, installing anchors is pretty simple. You only need 3 things: a drilling rig, a grout pump, and a rotary mixer. The drilling rig can come in form of, as you see the top photo, which is used with abseiling equipment. You can also get excavator based and handheld, but this is all dependent on the size of the hole, the depth, and where you can actually get the equipment. And then some key installation considerations is the angle between the anchor and the pull direction. And this is really key because rock anchors, the way they work, they're most strong in tension and about half that strength in shear. So making sure that angle is as close to 0 means that the holding capacity is maxed out and that we're less away from failure. And then secondly, the addition of centralizers. Centralizers are key to ensuring that the tendon itself is in the center of the borehole, therefore the grout is evenly distributed around it, and therefore the holding capacity is again at maximum capacity. Testing information. So as I explained, the acceptance test, now that is actually required by law for all working anchors, so that needs to be done. And it's basically just to determine if the anchor can hold the minimum design load. Now, the second test is a sacrificial investigation test. And this is usually conducted when not a lot of geotechnical information is known about the area, or there's not a lot of anchoring experience being done. So basically, this one is not required, but it is recommended. So you can save costs by producing an actual working anchor, as you can sort of upscale a smaller anchor to ensure you're not overcompensating or undercompensating. And those two standards down the bottom are based on my findings, and you'll see more of them in the report. And yeah, that's just where to look for further information. Now, moving into objective 3, anchor design considerations. The first is the type of tendon and tendon diameter. So there's 3 types of tendons. You've got a wire rope, you've got a rock bolt or rebar, and you've got a cable bolt. Now, at short embedded lengths, which is under 15 meters, it's not really, there's no difference to pick one over the other. There's no advantage to it, but anything over 15 meters, you should go with a cable bolt. That's industry standard. But for forestry applications, it's unlikely that we'll need anything close to 15 meters. And then obviously increasing the tendon diameter increases the ultimate breaking strength, pretty simple stuff. And for the wire rope and cable bolt tendons, you can, these are quite bendy, so you can bend them over and use a double tendon that's seen in that design on the right. And this will also increase the holding capacity. The second design consideration is the length of the bonded tendon. So increasing the length increases the shear mobilization and therefore increases the holding capacity. But however, it does come increased costs, more grout, deeper hole, wider hole, and a longer tendon. Next, we have the shape of the tendon. So as you can see, for cable bolts, we have vertic caging, and for wire ropes and rock bolts, we have, you can add lugs. So these induce a compressive stress, which increases the holding capacity as this compressive and shear strength stresses work together. But however, again, these are likely to increase costs. Finally, grout properties. So literature states a water to cement ratio of 0.34 to 0.4 is a good range for your grout to be in. Anything less than that, and you're likely to have trouble actually pumping the grout in, and anything more than that, it just gets a bit messy. For general purpose cement, that's pretty much the go-to for these anchors. We don't need anything too high grade or high tensile sort of concrete. The main key things for grout is just making sure there are no air pockets present. If you're going with a grout anchor company, they will know what to do. But yeah, if you're installing it yourself, probably good to have someone show you what to do, and then allow for a suitable curing time. So we recommend about 7 days as safe before any work or testing is done on them. And finally, to finish up, I explored a couple of alternative applications where grouted rock anchors may be used. As you can see, this was quite a nifty little slash track design. Involves grouted rock anchors installed into the hill, which hold the netting over the water. And the cool things about this design is it actually doesn't cause any disturbance to the stream bed or potential fish passage. And in case of large weather events, it also reinforces the bank to prevent major erosion or possible collapse. And compared to those big concrete structures we see, it is likely to be cheaper. And then the final application I looked at is tailhold anchors. So these basically are the same principle as skyline anchors. However, their loads are likely to be higher. So it is more, so we need a greater anchor design capacity, or we need more anchors. However, there are a lot of downsides to grouted anchors as tailholds, and is that they cannot be moved, they cannot be reused, and they cannot be recycled once they've been installed. So once they're in, they're there for good. So unlike a mobile tailhold, they're not really versatile and they can't be used over a great distance. Yeah, thank you.
All right, thank you very much, Patrick. Yeah. Okay, great. Yeah, some questions for Patrick with regard to the anchoring systems. Questions from the audience? So So Patrick, can you just mention what are some examples? It's Manulife, so Manulife installed the anchor that you've tested.
Yeah.
What is the likelihood of them continuing to use? Was it kind of a one-off trial, or do you think they will regularly apply that particular technique to help secure their yards?
I think if they had any similar situations, they would use it again. There are definitely things they could change, like bringing the anchor costs down, particularly the rigging technique. There's probably a lot of work to sort of optimize what sort of anchor is best. Obviously, for that design, 6 meters, it's quite overcompensated, especially with 3 anchors. So they've definitely spent more money than they could have. Yeah.
Okay, very good. Okay, any other questions from the audience? Otherwise, we will move on to the next and final presentation. All right, thank you very much, Patrick. Great.